the School of Public Health. And now we're going to hear from Dr. Scott Comulada, who's got his degree in some department or other, the biostat department here, in 2006. So welcome, Scott.
Thank you. Well, I have to say, when I analyzed my dissertation data, I used data on sex and drugs. I also incorporated teratology data on rats. So my title is going to be Sex, Drugs, and Small Animals, but Dr. Weiss said he wouldn't hood me unless I changed the title to something else. So I didn't use that title. Well, we got a really nice overview last week from Dallas and Nithya on general conceptual designs related to mobile phone research. And Jay, we just heard from him on when you're in the focus group stage, some more qualitative type analyses you can do. So I'm going to wrap things up now between the talks and talk about, okay, you've designed the study, you've done your focus groups, and now you're ready to analyze this mobile phone data. So what do we do with it? So before I launch into analyses, I'm going to talk about some conceptual issues related to the analyses. So when we talk about EMA data, we're focusing on mobile phone research, but really EMA data is really any data predicting couple breakup. If I ask you about your relationships with a spouse using mobile phones on a daily basis, that might not do as well a job as if I have you try to reconstruct over the past 3 months. You might get a better picture of what's really going on. So it's not always a clear-cut solution. One is not necessarily better than the other. And when we go to analyze the data, these are all things we need to keep in mind besides, the raw numbers. And really, a direction of bias between EMA and recall, it's not always clear-cut in the literature. What we do know is that, in general, EMA will give us a higher number of responses for drug use. There's one article, I think it's on this page though, where EMA actually resulted in a lower number of responses for sexual activity. It's a clear-cut case. I think something we have to be really careful about too when we compare EMA versus recall data is understanding what is the gold standard. I think there's a temptation with EMA data to say, well, it's closer to the truth, that should be the gold standard. But we have to be careful with that. And the reason I put this slide in there is because it's really easy to start using terms like, well, recall underreported this or that, overreported, when in fact we don't really know which one is the truth. And I'm going to just give you a simple example to show how the issue is not so clear-cut. This is mobile data from a pilot study from one of the researchers at our center. And this is among adolescents, where they were queried on alcohol use, drug use, and several other things over, I believe it was about 6 weeks. And what's really cool with this study is they used 3 methods to assess substance use. The first was through mobile phones. They used SMS, text messaging, based questionnaire. The second one was at the end of the study. They asked them to reconstruct or recall their substance use. So they actually gave them what we call a timeline follow-back method, where they literally showed them a calendar, and for each of the days they said, can you tell us, did you use drugs on this day, and so forth. And then lastly, they also did urine testing twice a week. So in this particular example, if we look at the top one with EMA, now these are 2 individuals.
Are they adolescents, out of curiosity?
Yeah, these are adolescents.
Late teens?
They're early teens. I forgot the exact age range, but they're early teens. And I believe they were in treatment. Do you remember, Dallas?
Yeah, they're in outpatient treatment study.
That's right, outpatient. So this, probably is not reflective of adolescence in general. But
I was just curious.
Yeah.
Didn't want to tar the whole group.
No.
But I think it's interesting because based on the urine test, there's only one, instance where alcohol was consumed, but they tend to over-report across
Reported.
Yeah, so I guess what I was going to say with the urine testing, as Jay pointed out, urine testing, it's not always clear-cut. There's definitely a problem with false negatives. But
although those days they don't have tests on the
What's the
urine.
frequency in the first two, actually?
well, they get tested about twice a week.
The first two calls? Oh, I think it's more frequent, right?
I'm sorry, which one?
Talk to
The EMA and recall tests.
Oh, I'm sorry. So the EMA is daily. Should mention that. They have the opportunity.
Well, there's also a
Recall is also daily. That's an important point. Yeah.
Recall is retrospective.
Recall is retrospective. That's a good point. Thank you. The EMA is daily. Whether they do it or not, they're supposed to do it daily. And for the alcohol testing, urine testing, it's supposed to cover roughly 3 days. Although whether or not it really does, there's some debate on that. So like, for example, on this date where they got any of these dates, you should be able to go back about 3 days. So there's a little bit of coverage. So it is kind of disturbing that, this doesn't quite match up as well as we would hope. But I think it speaks to, besides probably maybe better testing, it's not always a clear cut which is the gold standard. And I think another thing that, yes.
So if we assume that the urine test is somewhat reliable, I think it goes back to your point about how we have trouble remembering things that we do on a regular basis. So if these are kids that kind of consume alcohol on a regular basis, it might be more difficult for them to kind of, figure out when it is exactly that, they consume alcohol. So,
right. But the EMA, that's a little more disturbing because it's daily. But I guess speaking to what you said, they actually can fill those out anytime during the day. So maybe it's late at night and I'm just going through saying, yeah, I guess I used today, and so it's,
yeah,
yes.
Just kind of saying like adolescents, knowing that they're going to be tested on the phone, maybe, it's like kind of a bravado type of thing. Yeah, I've done it every day.
Right.
So unless you have somebody to check upon them.
Exactly.
I don't know.
That's, yeah, and that's a good point. Yes, Dallas.
Well, and the flip side is that people would consider the biological marker, the urine test, as the gold standard.
Right.
But like you said, there's false negative problems. There could be issues, especially with an alcohol test, which we discussed earlier, that it may not pick up, let's say, a single alcoholic beverage.
Right.
These kinds of like cutoff.
Exactly.
So, maybe you have to have 3 or 4 or 5 drinks to really get a strong signal in the urine test.
Right.
I would be more inclined to believe the EMA data over the
Right.
urine test data.
Yeah, I definitely would too, even though, as you pointed out, there could be over-reporting. So I guess there's another issue too that this slide brings up, which is a challenge for analysts. If you want to compare recall and EMA, as we can see, people don't always report on every day for EMA. So if we did a traditional type analysis, say like correlation, where you tried to just pair up observations on days, you're going to throw out a lot of observations unnecessarily. So one of the big issues with analyzing this type of data is how do you group observations? Because to some degree, you're probably going to end up doing that. Do you group it by several days if they gave a positive response within that window? So I think that's an issue that hasn't really been worked out yet. At least I haven't.
Well, and as we discussed earlier, Scott and I talked about this earlier today. We were pretty excited about it, so I'm just recalling some of the points. Another, since Tom Bellin isn't here, but another interesting point that I'm sure he would discuss a little bit would be imputing missing data. I mean, with 3 kinds of data, is there the possibility that we could use the recall data and the urine test data to sort of impute the missing values on the EMA data? What would that mean or look like? And you're talking about substance use. You see on the graph on the right, the person has a positive alcohol test around April 11th, and then there's a bunch of missing data on the EMA immediately following that.
Right.
which, you know, from the kind of substance use perspective, would make sense that they would stop reporting when they were using.
Right. Yeah.
This is the kind of thing, I think imputation is a little bit, isn't quite necessarily the right thing. There's sort of an underlying gold standard that, you know, theoretical that you could posit. And then you could set up a model that fits, well, that generates EMA and recall and urine tests given the underlying gold standard. Now, I suspect that there's just going to be, unless you can like stick a camera on a beanie on top of their head for, you know, the duration of
We're working on
March
that.
and April. Okay, maybe just a small one with Google Glasses.
Yeah.
Then it's,
That's right.
you know, you're going to be, it's going to be permanently missing data. That gold standard doesn't exist.
Right.
But you could maybe set up things that at least give you sensitivity analysis. I'm not sure you could actually get full inference without enough assumptions. You could, but it would have so many assumptions that you'd really want to call it a sensitivity analysis and not a full model fit.
Got it.
Right. Yeah.
But it'd be fun to do.
Right.
It's doable.
Right.
I'm not sure. You learn more. You might learn more about what you're thinking rather than about what people are doing, which is not quite the same thing as what you'd want. That's why the beanie
Right.
or the Google
Yeah.
Glasses would be nice to have.
So the last thing I take away from this slide is this really emphasizes the importance of visualizing the data. You know, a lot of times there's a temptation to just jump in with really cool tools and start analyzing, but probably even more so with EMA data than other types of data. You really have to visualize. I know if you have the opportunity to take a Dr. Weiss class, he emphasizes the importance of that with longitudinal data, to visualize it. And as we can see with EMA data, that might be even more. So yeah. So this is just my another warning. I don't know why I picked that picture, but this is just another warning that simply aggregating the data, as there's a temptation to do, can be dangerous in this case, even though we might have to do it. I'm going to give you kind of a silly example just to drive home my point about the danger of aggregation. So this is from that same pilot study, just aggregating the data across those two people. And this is the alcohol use again. If I just looked at the numbers, so this is saying, okay, we recorded 8 days of use for EMA and 8 for recall. Now there's more missing days for EMA than recall, but if I just looked at this, you might be tempted to say that, well, use is pretty similar between the two. But actually, if we go back to our picture and we deaggregate the data and just look at it in its raw form, we can see that person 1 does tend to report more on EMA, but person 2 tends to report more on recall. So even though the total count is 8 in both cases, we see very two different pictures. So this is another important thing with EMA data, in that the individual variation becomes very important, because typically we have a small number of individuals and we're really interested in looking at individual behavior much more so than in a traditional study. And just the last kind of a little, I guess, warning here. Whether we use EMA or recall, the fact is we don't really know the truth. Usually we're using past data and we talk about prediction, but we don't really know which is the truth or which is the gold standard. So anyways, I just like this little quote here. It's kind of applicable. All right, so now I'm actually going to get into more of the analysis. Now that I've talked about conceptual issues, a lot of this draws heavily on a couple of really useful resource books, one by Walls and Schaefer, another by Stone, Schiffman, and forgot the other names, but they're in the reference there. The really cool thing about this is this melds various fields of statistics. We especially draw very heavily on economics. I just threw this in there. I like this little quote that Economics is a science with excellent tools for gaining answers, but a serious shortage of interesting questions. That's not exactly true. It's a little facetious, but I guess what I'd like to say for behavioral researchers, we can't wait to get our hands on these time series analysis type tools because we have a lot of good uses for them. And just to kind of put this in a paradigm between when we talk about traditional longitudinal analyses. Oh, hi Tom, welcome.
You're right on time.
We were just talking about multiple imputation and that, and your name came up. So kind of to put it into a frame between traditional longitudinal analyses and EMA data, in the typical setting, say with the clinical trial, we're really interested in group differences. You know, we might have two groups, treatment and control, and we have maybe 3 or 4 time points. And so it's really the group means that are the focus. Whereas with EMA analysis, a really nice paradigm is the N of 1 trial. And the idea with an N of 1 trial is that in chronic illnesses, you often tweak the medication that you give a person over a long period of time. You might up the dose, lower the dose, you might change the medication, and in a sense the person acts as their own control because you're really seeing how they change over time in their response to the medication. And that response can be very different across individuals. So you're really focusing on that one person, and you can have many, many observations. So that's where this idea of N of 1 trials. So this EMA framework of collecting a lot of data points on individuals fits into that. In a behavioral HIV setting, it could be that we do a better job of predicting adherence or seeing how that tracks with mood and other characteristics over time. Yes.
Like time series data, you just care about that same individual and prediction of that same individual later, right? So you're like that same person. But in the EMA setting, you still care about the other people. You just haven't measured about that.
You do, and you care about both. That's the paradigm is probably a little bit extreme. So certainly, like for example, in the data I'm going to show, we have 32 people. And even though we're focused on individual differences, we do care about the group effect, so we can make some kind of general statement. So you still care about both, very much so. So these are just 2 challenges in working with Dallas and Nithya on these mobile phone studies that I see is really specific to cellular EMA. I don't know if this is an official term, SEMA, but one of the PIs at our center started to use it, so I'm kind of using it now. So one of the things is when you have a mobile phone, you have a small screen size. And you don't want to have to force people to scroll down to use a slider bar or some other metric for a continuous measure. In some cases you might, but really if you can have people clicking yes, no buttons, especially if they have to do it a lot, it's just a lot easier for them. So with mobile data, we end up with a lot of categorical data. And that's something we have to deal with. Another issue which I mentioned on the previous slide, specific to mobile phone data, we can collect a lot of different data types. You know, we have the recall, we have the EMA. As biomarkers get incorporated into mobile phones, like blood tests and different things, we'll have those kinds of data points. But how do you group them? Maybe the observations are not all measured on the same day. How do you decide how to group them if you want to compare different methods? So that's not an easy issue necessarily. So now I'm going to talk about just a general analytic approach that I would take if I was given an EMA data set. And towards the end of the talk, I'm going to show an actual data set and give it as an example, but I'm just going to start with a general approach. So again, if you have the opportunity to take a Dr. Weiss class, one of the first things we go over, even for traditional longitudinal analyses, before we launch in and looking at predictors of the outcome, which might be our ultimate interest, we first need to figure out how the outcome behaves over time. What kind of temporal patterns do we have? Are there seasonal patterns? Are there weekly patterns where the outcome fluctuates up and down? So we really need to tease out those kind of relationships first before we start throwing in other covariates. So the first step in modeling, before we put in covariates, might be to fit a longitudinal model with time, parameters of time. And there's just such a wealth of literature on this. Walls and Schaefer do a nice job of summarizing some of the issues. One of the big things with EMA data is, in a typical longitudinal analysis, we model correlations between repeated observations, but we assume those autocorrelations are the same across individuals because we don't have many time points. And usually we have to come up with a parsimonious model that just assumes equal correlations between individuals. Well, when we get into EMA data, we might be able to model different correlations between individuals. And the Walls and Schaefer example, they give some nice examples in SAS, some code that you can use to test that. So that's an important thing. I mentioned the seasonal, weekly differences. I'm going to talk about this one a little bit more when we get to, yes.
Assuming some sort of stationarity to do it individual specific, right?
Yes, that's true. The stationarity assumptions, they come into play, very important that you need to test with the variances and the means and things like that.
That individual specific is not possible if it was changing all the time.
Exactly. You're right. That is a good point. So stationarity is an important assumption as well. And testing that, not just assuming that. Yeah. So once we've explored the temporal pattern of the outcome itself, then we can start adding in covariates. Now, as with any regression, we can have covariates that don't vary over time. We can have time-varying covariates. But one of the cool things with EMA data that gives us the possibility is not just to have time-varying covariates, but to also allow the regression coefficients themselves to vary over time. And again, I'm going to refer to Walls and Schaefer. I know I'm doing that a lot here, but they give really nice examples. And it's important to point out with time-varying coefficients, it's different from a time-varying covariate where we assume the effect of the coefficient is assumed to be constant. So the example that Walls and Schaefer give in their chapter is a study, I believe it was a smoking study, and you had people in treatment before smoking and after. And I think the outcome in that case was mood. So they actually modeled one regression coefficient for individuals before they quit smoking and one after. So that would be a case where you have a lot of observations, and so you're actually able to do that. Whereas with a traditional longitudinal analysis, if you only have a few time points, you probably can't do that. Another example given in a paper by Hedeker in 2009, you can also, if you have a lot of observations, you can also put in coefficients for the regression or the random effect variances themselves. You can look at predictors of that. And in their particular example, they looked at EMA data in students over 7 days. They actually modeled the variance of an ordinal mood outcome, and their predictor was whether or not the student, I believe, had smoked during that time period. So they allowed two groups with variance components, and they give again SAS code for the NL mixed procedure. But they had a very large sample size, so that's pretty hard to do with a smaller sample. And so before I get into the practical example, I'm just going to give another modeling option. I know I've been throwing a lot of general things out there because it's such a broad field. One thing is so far we've just been talking about regression analyses with a single outcome. And a lot of times this works, but a big assumption is that you have an a priori causal pathway. But it might be harder when you talk in a longitudinal setting to decide which is the predictor and which is the outcome. An example of this in HIV research, when you're modeling mental health symptoms and drug use over time, well, there's different theories. There's theories that people self-medicate with drugs. So as mental health symptoms go up, drug use can also increase, but there's also competing theories where drug use influences mental health symptoms. So the causal pathway is not always clear-cut, and so by using bivariate models, you can actually test those relationships simultaneously within the same model. But just in my own experience with these models, again, the limitation is you need a big sample size. That's what I've found. Very large, hundreds of people, or else this just won't work. Which is one of the reasons I'm showing you all these things conceptually, because our data set is quite small. And while these are really cool tools, we couldn't use them in our data set. So I'm just giving you an overview. So now I am going to talk about our data set that we collected. And this was with 32 HIV positive individuals, mostly recruited from AIDS Project Los Angeles. I said mostly because I think we had one person from LA Gay and Lesbian Center. Is that right, Dallas?
Yeah, there's new recruiting happening there, but I think everybody in this data set's probably from India.
Okay. Yeah. They were followed over 6 weeks, and these are the 32 people that were given mobile phones, and they were asked to record sex, drugs, mood, adherence, and possibly some other behaviors over a period of 6 weeks. So for this illustration, there's a lot of things we want to look at with this data, but I'm actually going to talk about the relationship between mood and medication adherence. So obviously for HIV, medication adherence is a really big deal. And one of the hypothesized correlates of medication adherence is mood. Although the past research based on recall studies is not very clear-cut. There are some findings that mood influences medication adherence, but there's very inconsistent findings. There's some studies that show a relationship, others that don't. At the bottom here, I just put a fairly recent RAND press release that depression is associated with lower adherence to medications for chronic illnesses. So that's not HIV specific, but it's just, I think they looked at diabetes, medication, and different things. So we suspect that there's a relationship, but with recall type studies, it's been hard to tease that out, possibly because mood, as it changes on a daily basis, it influences adherence, but it's hard to pick that up in a recall type study. So I'm going to show you, these are 4 individuals in this Chipts study, and this is just a visualization of the 2 measures that we're going to analyze. So one of them is a variable for the level of sadness, and I believe the exact question was, are you feeling sad today? Or Dallas, I'm going to call on you. I think that's what it was, something like that.
Yeah, it's from the CDC Health-Related Quality of Life questionnaire.
All right.
Which is like a retrospective, and we just adapted it to be every day. And we liked it because there are 4 brief questions, and one of them is basically depression, but it's are you sad, blue, or depressed?
Right. It's good to have Dallas here. I get to cheat a little bit and defer to him on that. So the question ranges from 0 to 3. The other question for medication adherence was, did you take your medication? And this wasn't specific to HIV medications, right, Dallas? But the implication was they're all HIV positive individuals, so that would be the most relevant medication.
It wasn't necessarily antiretroviral meds, it was any medication.
Right. And they could actually answer these questions several times a day. So what I've done with this data is I added a little bit of jitter to the observations so they don't completely overlap, and you can see the hollow observations or any observations before noon, noon or later, or solid. So this is a little bit hard to see any patterns because there's so many dots and points. As a next step, I simply took the mean of the observations over each day. So this is a little bit easier on the eyes to look at. So for example, this point here is averaged across their mood responses for that day.
This is one individual.
Yes, these are 4 individuals. This is 1 individual. This response here is 100% compliance. So if they said they took all their medications during that day. So I purposely chose these 2 individuals because there was some variability in adherence responses. In truth, most people in the data set looked more like over here, where they were fairly adherent to medications. Another thing that this data, just looking at these 2 individuals, points out, which is another important point to EMA data, you notice this person's, if we could call it a baseline level of sadness, looks like it's possibly a little bit lower than this person's baseline level of sadness. So one of the issues in the EMA literature when you analyze EMA data is a lot of times it's customary to subtract off the mean for each individual for the observations related to that individual. So as opposed to oh, go ahead, were you going to?
Sorry,
Yeah.
I was just curious, so just to clarify, this is not a significant 6 weeks, right? So if we were going to look at some relationship between these 2 things, we don't care about the time effect, would we? Because it's sort of like we're interested in average association.
Right, and in fact, that is a good point with the time. And in fact, we don't really expect a time effect because there's no intervention. We might want to see if there's a time effect, but you're right. It's definitely not the interest. We're really just interested in the association. So one of the first things I did do with the data, even though this is a binomial outcome, is just to look for, are there any kind of temporal patterns in the data before we start looking at mood as a predictor. And one of the things is possibly there's a weekly or daily pattern, should be daily pattern with adherence. I know for myself, had to give my dog medication recently and for some allergy, and I have to say that on the weekends, he didn't get his medication as much as he should have. Now that's a bad example because obviously life and death with HIV medication is more serious, but I think with all of us on the weekend things tend to slide sometimes. So it's not unreasonable we might see different patterns on the weekend than the weekday. So I mean, one of the simple ways we can do this, we can fit a random effect logistic model in SAS to the adherence outcome. We can put in effects for days of the week or however else we want to partition that out and see if there's anything there. I didn't actually find anything, and this is a representation again of those 4 people, only this time it's just by day of the week. And so obviously they have multiple observations for each day that span the study time. So just looking at this, you don't really see a pattern. It's kind of hard to see if there's anything for mood or adherence. And this is pretty representative of the other observations in the data. I'm only showing you 4, but yes.
So how many times were they taking the medications, like multiple times a day?
Yeah, I think on average, most people listed probably 2 or 3 times. I don't think I really saw anyone above 3.
But that's how many times they're supposed to take it.
Usually it's twice, and Dallas might be able to.
So they were prompted to report on their mood 4 times a day.
Right.
And they were prompted to report on medication adherence once a day. And for most of the HIV meds, it's 1 time a day. And many of the folks were also probably taking some kind of psychiatric medication.
Oh, that's right.
As an alternative or
Yeah.
in addition to HIV meds.
Right.
So
Yes.
if you in that case subtract the subject-specific variable, as you were saying for the mood, right? Your model is trying to tell if the binary adherence affected by your sort of changes from your own mean level in the mood. Right?
Exactly. And again, that brings up a good point about it. It really depends on your research question. Like a lot of times you might be more interested in changes from your own mood. Whereas if you don't subtract off the mean, then it's more maybe population based. Yeah. Any other questions? Okay. All right. So I talked in general about a lot of really cool analytic time series techniques. Fortunately, there wasn't a lot of variability in adherence, and that's a good thing, because that means the participants are doing what they should be. I think with HIV medication, you want to be, I forgot if it's 90, probably closer to 95% adherent to keep on track. And it is worth mentioning the participants in this study recruited from APLA were mostly an older population. So they probably had been taking medications for quite a while, probably more experienced. And so we would expect that there's just not a lot of variability. So with the small number of participants, 29, that we have information on, 11 of those reported 100% across all the time points. And 19 reported adherence across more than 90% of their time points. Yes, Dallas?
I'll just throw in another piece from our qualitative data. So every 2 weeks we're also doing telephone interviews with people asking about their experiences using the cell phone application. And several participants reported that that the phone application helped them to be adherent, because the prompts for reporting on medication adherence also, they recognize acted as medication adherence reminders. So we kind of have a little bit of a reactivity issue here, which is what we'd like to see from an intervention perspective.
Right.
But it messes with our data. And someday we can compare this with a control group we have, which are people who just did, about 1/3 of the participants who just did web surveys with retrospective reports of adherence.
Right. That's a good point, too.
So conceivably, you get a prompt and you say, oh, I forgot to take my medication. And
right. Exactly. Yeah.
I think the adherence info is interesting, especially the fact that adherence, this includes, ART as well as some of the other medications. So
right.
If we assume that one of the additional medications that they're taking is indeed like a mood, like antipsychotic, where it actually helps them with the mood, then that has different impact on the relationship between adherence and the level of mood.
Right.
And some of the drugs may influence mood in a negative way. So one of the side effects of HIV medication might be irritability or mood. But then if you're also taking drugs that will help you with the mood, that might kind of offset the different effects of different drugs.
Right. Yeah, that's a good point. Okay, so what can we do with this? Well, here's one analysis that I did, and this is really all in the preliminary stage so far. But I kind of thought, okay, there's not a lot of variability, but it might be interesting to see Does mood predict if people are adherent all the time? You have those people versus people that might fluctuate a little bit. That might be kind of interesting to look at. So one possibility is if we use a mixture model. And I haven't talked about this yet as in the toolbox of types of analyses, but this is also very applicable to EMA data because as you increase the number of time points, you have more information about the trajectory. And so it's kind of interesting. So the idea here is with a typical regression, we're interested in looking at correlates or predictors of a mean level of one trajectory, whereas with a mixture model, we don't assume everybody has one mean level that they vary around. We can estimate two or more trajectories. So let me just show you. It's probably a little bit easier to see. So this was fit in SAS using the Proctrage procedure. And with 29 individuals, you can't really get much more than two groups. You might be able to force the model to do that, but it might not make a lot of sense. So what we're looking at, these are the days on the x-axis. This is the probability of adherence. The dotted line is what's predicted by the model, and then the variations around it are the observed. So not surprisingly, just from looking at the raw data, you have your two groups where one group is people that are pretty much always adherent, and then you have your other group where, you know, there are some fluctuations and they're not always as adherent. So what I put in the model here, this linear, here you have your intercept just like you would in any regression model. We have a linear term for time, which is not significant. And as you pointed out, time is not the main focus here, but I have it in the model. And then with this other predictor down here for sadness, that's just that mood variable, the ordinal measure. So the higher you are on that measure, the less adherent you are. That's what this negative relationship implies. So what's interesting about this, looking at this with the two groups, so group one are the people down here who are less adherent. So just based on the model, of course I have to do more in depth before we draw definitive conclusions, but based on the model, what this tells us is that people who are less adherent, sadness has an impact on their adherence in this group. But for the people who are adherent, the people up here on top, if we look at the p-value for sadness, we don't see an impact. And this just tells us, this group membership tells us the probability of people being classified into those.
So in this model, did you specify the number of groups?
I did, and that's a good question. What I did, I mean, again, there's only 29 people, so it's hard to really, you know, go beyond or do a lot of cool model fitting. But one of the things you can use with Proctrage in deciding the number of groups, I toyed with 3 groups as well. If you look at this BIC statistic, which is, I don't know if you guys can see, I guess it's kind of low on here. So Proctrage gives you 2 Bayesian information criteria and statistics. One is based on the number of observations, or in this case the number, I should say, of individuals in the data set, which is the 29. The other thing it gives you is a BIC based on the total number of observations, which in this case is 736. So we have 2 BIC statistics. If you take this BIC statistic, or each of these, and you compare them, which I did, to a model that has 3 groups instead of 2, and I believe there's a general rule of thumb that if you take if you subtract off the simpler model from BIC for this model, you take the natural log of that and multiply that by 2, you roughly get a Bayes factor that you can then use to compare, whether or not you want 2 or 3 groups. And so in doing that, the 2-group model based on that criterion came out better. The 3-group model didn't add, really add to that. And I should mention too, when I did the comparison between 2 and 3 groups, I did that before I put sadness in, because it probably wouldn't be fair to compare this 2-group model with sadness to a 3-group model without. So I started by just looking at the trajectory and doing 2 versus 3 group. And it also gives you an AIC criteria down here, which you can use as well as a model fit statistics. And that came out to be the same.
I guess if you have one group, if you go to the mixture model, then it's not significant, right? Sadness is not significant.
Well, we actually, no, it actually is. I didn't talk about that because there's a lot of different things, but we did fit just a really simple model that had a time varying covariate for sadness, predicting adherence, and that actually did come out significant. I guess I thought this was a little more interesting to look at too, but you're right, that it did come out.
The coefficient here for the first group might be larger.
Right, yeah. So that's, any other questions?
So
Yes.
you figured out how many groups to have, and how did you assign individuals to groups once you knew that?
Oh, that's a good point. So with this procedure, the groups are not really deterministic in that you don't assign them to the groups. What happens is the model itself, you let the model decide. So this group membership is not a hardcore thing that we're assigning these people to these groups. This is saying based on the model specification and the model fitting, we're predicting that this percentage of people fall into these categories. So we allow some variation rather than assuming we know that, for example, people who happen to report 100% really are always going to be 100% adherent.
So when you're writing your paper, you're just going to describe them as the adherent and the non-adherent, sort of more adherent, sort of less adherent group.
Right.
So when you're interpreting it, you just kind of have to make some stuff up.
Well, no, not quite. What you can do, which I didn't get to yet, but you can also see how well the predicted group membership really fits people's actual patterns of use. So you can get an idea of how well that really fits. So I would definitely talk about what I observed in the paper as well as, what the model came out with. But it is, I guess to be honest, the language, the way I've seen people describe these models is a little bit nebulous. Yeah. Yes, Tom.
On this issue of the compliance behavior possibly being influenced by the query that you're providing, I wonder whether it would actually be possible to collect some data on that question, ask people, did you take your medications within the last 10 minutes? Do you think you would have taken your medications today if you hadn't been prompted? Some people might be willing to give you some information on that. I feel like it's still kind of early in the development of the science in this area, and that it might be openings for learning something about patterns of behavior that might be useful.
Right. Speaking to that, I kind of simplified the data a bit, but we do have a couple of more questions on adherence. One of them is did you take your medication on time? Another one was, do you remember, Dallas? There was on time, and then there was
There was just took it or not, and then on time.
Those were the two. Okay, so we did get a sense for whether or not they took it on time, and I think most people, if they indicated that they took their medication, it was on time or fairly close to when they were supposed to take it. Yeah. All right. Okay. Sure. That's a good stopping point.
So let's thank both our speakers. And maybe if there's any discussion, informally go up and talk to Scott afterwards. It's our hour is upon us on the